We're going to be talking about parallel and perpendicular lines in this lesson. The first thing I want you to do is I want you to look at this graph. Suppose you were to graph the two equations, y equals 3x plus 2 and y equals 3x minus 1 on the same coordinate graph. What do you suppose will happen? Well, let's go ahead and graph them and see what we can get. I'm going to try to get as close to the point as I can. There's my y-intercept, 3x plus 2. I go up 3 over 1. Up 3 over 1, and you draw your line through those 3 points. Then you're going to do the other one. You start at negative 1, and you go up 3 over 1, up 3 over 1, and you draw this line. All right, and what do you see? It appears that the two lines are parallel. Now let's look and let's graph these two lines on the same set of coordinates, and let's see if we can figure out what's going to happen now. This time we have y equals negative 3x plus 2 and y equals 1/3 x minus 1. So we're going to start at 2, then we're going to go down 1, 2, 3 to the right 1, because this is a decreasing slope, down 1, 2, 3 to the right 1. We're going to draw this line through here. All right, and now we're going to do the other line. We're going to start at negative 1, and we're going to go up 1 over 1, 2, 3, up 1 over 1, 2, 3, and we're going to draw the line connecting these two. And this time, you might notice that they're not parallel lines, but instead they are perpendicular lines. They meet at a right angle. So we should be able to draw the conclusion that if we have two lines that have the same slope, they are parallel. And if we have two lines that have opposite reciprocal slopes, that is, one's positive, one's negative, and they're reciprocals of each other, they are perpendicular. Okay? So that's something that we need to remember. All right, so look at evaluating and looking at equations that you'll be given to determine whether they are linear relationships. So what do you think the first thing you would do if you were given an equation and you want to figure out if it's a linear relationship? Well, you would actually want to put it in the form y equals mx plus b to see if there's any kind of a linear relationship. So if we had this equation right here, the first thing we would want to do is to get rid of the 2. So we're going to multiply both sides by 2. Okay, there's a 2 over here. So you end up with 2y. Let's do that in a well, never mind. I'm going to erase that real quick. I wanted to do it in a different color. Okay, so that would be 2y equals, now these are going to cancel out, so I have 4x plus 2 times 3 plus x minus 2. So now I have the distributive property here that I need to perform. So I have 2y is equal to 4x plus 6 plus 2x minus 2. Now we want to combine like terms. So we have this and we have this, which will give me 6x, and then we have this 6 and a minus 2 will give me plus 4, and I still have my 2y over here. Now to get y by itself, the last thing I need to do is divide every single term by 2, and I end up with y is equal to 3x plus 2. So you can determine from here that this is linear. So if you can get it in the form y equals mx plus b, then you can tell that it is linear. So how do we use this information that we have been given about whether they are parallel or perpendicular lines and what has to do with their slopes? Well, the one thing you should be able to do is write an equation similar to what we did last unit. So if it says write the equation of the line that is parallel to the line y equals 2x minus 2 and passes through the point 4, negative 1. Well, if you remember from the earlier slide, that parallel lines mean they have the same slope. All right, so if they have the same slope, then that means we're going to use this slope right here from this equation in our new one, and you would put it into y equals mx plus b. All right, so we have, here's our x coordinate, here's our y coordinate, so we have negative 1 equals m, which is 2, times our x coordinate, which is 4, plus b. So I have negative 1 equals 8 plus b. Then I subtract 8, and I have negative 9 is equal to b. So our equation is y equals 2x minus 9. So there's our equation. Now what were perpendicular lines? Now this time they're perpendicular. So remember, perpendicular is opposite and reciprocal. Okay? So now we want to use the opposite reciprocal of this slope. We want to use m is equal to opposite and reciprocal. So now I would plug in my points. There's my x and here's my y. So I have negative 1 is equal to the slope, which is now negative 1/2, times x coordinate, which is 4, plus b. So I have negative 1 is equal to negative 2 plus b. I'm going to add 2, and I get 1 is equal to b. So the perpendicular line, that's the line that's perpendicular to this line and passes through that point, would be y equals negative 1/2 x plus 1. Now looking at the next one, we have, now this last page that I have here, I want you to look at these examples. You have the first example, which is to determine if the lines are parallel or perpendicular to each other. And the second and third are to write equations of lines. So I want you to write these out on another sheet of paper and turn it in by tomorrow.